Hello everyone, I am Masood Ibn Abdul Wahid. Welcome to another video related to Arduino basics.
Any obstacle comes in the visibility of the sensor, the motor will be switched off. So now I have kept the obstacle around 13 centimeters. The distance is more than 10. So the motor is allowed to run. You can see the serial monitor, it is 6 centimeters. As it is more than 15, the threshold value, the motor is allowed to switch on. So when you move the obstacle close, the motor will be switched off.
So this is Arduino basics video number 3. Already we have discussed 2 videos. Today we are going to discuss about the controllability of electrical motor using Arduino with some of the basic sensors. In today's discussion, the first topic will be conditional on and off control of a DC motor using obstacle avoidance sensor. So this sensor is used to detect the presence of any obstacle just in the visibility of this sensor. So there is a transmitter and receiver. So this transmitter will emit out the IR light, and if it is not finding any obstacle just in the visibility of this sensor, it will not be reflected back at all. So when the transmitted light ray is not reflected back, by default the output of this sensor will be 1. If an obstacle is in the visibility of the sensor, then the transmitted IR light will fall on the obstacle and it will be reflected back. It will be received by the receiver of this module. And when the receiver collects the transmitted IR ray, the output will go low. So depending on these two conditions, we are going to control the electric motor. So with the output pin, there will be VCC and ground pin in the module, and you will be provided with a potentiometer. So the usage of this potentiometer is to tune the distance which is to be covered by this module. You can increase the visibility of this module and you can decrease the visibility of this module by tuning this potentiometer. So now we will discuss about the Arduino coding for using this module to control a DC motor.
So this is the program which we are going to use for controlling the electric motor. So to understand the program, just assume that the motor which we are going to control is equipped in a car. The obstacle avoidance sensor is used in pin number 2 and the motor which we are going to control is used in pin number 13, and we have declared the motor to be output device and the sensor to be input device. And to see the corresponding variation in the operation, we have begun the serial communication, and inside the loop function we have read the sensor value in terms of digital value from pin number 2, and that sensor value is printed on the serial monitor. If the read sensor value is 1, that means there is no obstacle in the visibility of the obstacle avoidance sensor, then in that case the road is clear, you can drive the car. And if any obstacle comes, that is written in the else condition. So if the sensor finds an obstacle, then we need to stop the car. So this is about the coding. So now we will connect the connection according to the circuit diagram, upload this, and we will control the motor accordingly.
So this is the motor which we are going to control. So this motor is connected to the battery through relay module.
So this is the IR based obstacle avoidance sensor. So the first pin is the VCC pin connected with the VCC line of the breadboard, and the second pin is ground pin of the module and connected with the ground line, and the third pin is the output pin connected with the second pin of the Arduino Uno board.
Connect the VCC of the relay module to the VCC line of the breadboard. Connect the ground pin of the relay module to the ground line of the breadboard. Connect the input of the relay module to pin number 13 of the Arduino Uno board.
Go to tools, select the board correctly, select the COM port correctly, and click the upload button. The code is uploaded. So now you can see in the serial monitor that there is no obstacle. So by default a digital output 1 is coming, so it means the road is clear. The car motor is switched on so that the car will be driven. If any obstacle comes in the visibility of the sensor, the motor will be switched off, and you can see that in the serial monitor also. An obstacle in the road, so the car motor is switched off. Once the obstacle is cleared, then the motor will be switched on. So this coverage distance, as I said, you can vary by adjusting this trim pot. So by using this sensor, we can find the obstacle and we can control the motor accordingly.
So now we are going to control the same motor using another sensor, which in this case it is ultrasonic sensor. So this sensor is very famous for measuring the distance. So we are going to use this sensor and we are going to find the distance between the car and the obstacle, and depending on the distance we are going to control the DC motor. Okay. So this is the ultrasonic sensor module. So in this one is the transmitter which will emit out the waves, and this is the receiver which will collect the waves upon hit by an obstacle. This module will have 4 pins, VCC and ground. There is extra 2 pins which is trigger and echo. Trigger means this is the pin from which we are going to emit out the ultrasonic waves, and echo is the pin which will receive the reflected ultrasonic waves. Without any obstacle, the ultrasonic waves will not be reflected back to the receiver. But if the ultrasonic wave finds an obstacle in front of it, so the emitted wave will be hit on the obstacle and it will be reflected back to the receiver. The time interval between the instance the module emits the ultrasonic wave and the instant it receives the ultrasonic waves, this time period will be calculated, and depending on that time period or depending on the time duration, we will decide what is the distance between the module and the obstacle, and according to the distance we are going to command the motor.
So this is the program which we are going to use for controlling the motor using ultrasonic sensor module. We are going to use the pin number 2 for triggering the ultrasonic wave. We are going to use pin number 3 for receiving the reflected ultrasonic wave, and we are going to connect the car motor in pin number 13. And there are 2 variables declared, one is duration and distance. This is to find the time period and to measure the distance between the obstacle and the module. And the trigger pin is going to be the output pin and the echo pin is the input pin, and the motor is nothing but our output device. And to see the variations in the operation, we have begun the serial communication. So inside the loop we are going to trigger the ultrasonic wave and it will be received by the echo pin. The time interval between the instant the wave is triggered and the instant the wave is received will be calculated, and it will be stored in the variable called duration. From the duration, we are going to arrive the distance between the obstacle and the sensor by this statement, and that distance is going to be printed in the serial monitor. We have opened the conditional statement that if the distance is more than this value, switch on the motor. If the distance is less than the set value, then the motor will be switched off. Now we will do the connection as per the circuit diagram and we will upload the code, then we will go for the trial.
This is the ultrasonic sensor module, this is the transmitter, and this is the receiver, and you have 4 pins, VCC, trigger, echo and ground. Connect accordingly. So just for information, the motor control loop in the programming is commented. The motor control input in the connection also not given. So this is just to show you how the ultrasonic sensor is measuring the obstacle distance. And now I am keeping an obstacle around 10 centimeters. You can see the serial monitor, it is displaying 10. I have kept the obstacle in around 6 or 5 centimeter, and now I am moving it back to 14 centimeter. So this is how you can use the ultrasonic sensor for measuring the distance. So now we will go into our actual work, uncomment the motor control loop, upload the program, connect to the motor control pin in pin number 13. So since there is no obstacle in front of the ultrasonic sensor, the car is driven or the motor is driven. So now I have kept the obstacle around 13 centimeters. Still now our condition not satisfied. The distance is more than 10. So the motor is allowed to run. You can see the serial monitor, it is 6 centimeter. According to the programming, the motor was switched off. If you move back the obstacle, the motor is allowed to run. So this is the program which we are going to use for controlling the same DC motor with ultrasonic sensor. We have included an OLED display. So for including that, all the program are same. Just I will highlight the commands related to OLED display. So in this statement we have included the graphics library, and in this statement we have included the OLED driver library, and this statement is to declare the width of the OLED display, and this is to declare the height of display, and this is the default address for the OLED display. So by using these statements, we have started the communication between the OLED display and the microcontroller board. So these are some statements related to OLED display by which we can clear the display, we can set the font size of the display, we can set the cursor position of the on the display, and we can print the commands or the read value on the display. Here we have opened the conditional statement that if the distance between the sensor and the obstacle is more than the threshold value, then do this action. If the distance between the sensor module and the obstacle is less than the threshold value, then do this action. That is what we have done here with the usage of OLED display accordingly. Now we are going to use this OLED display in addition to the serial monitor. So for that, connect the OLED display in the breadboard. Now the connections are completed as per the circuit diagram. Now before uploading the code, go to Sketches, include library, manage library. You need to include the Adafruit graphics library for OLED display and the driver library for the OLED display. For that, type Adafruit GFX. So this is the Adafruit graphics library. Install that. So you can see here the graphics library is installed. In the same way, you need to install the driver library. So that is here, SSD1306. Install that. So you can see that is also installed. Close this. Now you can go to tools, select the board correctly, select the COM port correctly, try uploading the code. Now you can see the serial monitor and the OLED display. Now you can cross check the OLED display value and the serial monitor value. Both are same. As there is no obstacle in the visibility of the ultrasonic sensor, the car motor is switched on. Now let us take a trial by placing some obstacle. As you can see here, the obstacle is placed near the 14 cm range. The OLED display also says it is 14 cm and the serial monitor also says it is 14 cm. So the motor is switched off. When you move out, now the obstacle was placed in 20 cm range. As it is more than 15, the threshold value, the motor is allowed to switch on. So when you move the obstacle close, the motor will be switched off. So this is how we can include the OLED display into our projects so that we can see what is the distance and what is the control operations happening during the execution of the project. You can upgrade this project so that you can implement a speed control of this DC motor according to the distance of the obstacle. If the distance is more, you can go with the full speed. If the distance is medium, you can reduce the speed to half. And if the distance is close enough, then you can reduce the speed or you can even switch off the motor. Hope you like the video. Hit the like button. Subscribe the channel for more videos yet to come. Let us meet in the next session. Until then, I am Masood Ibn Abdul Wahid signing off.